Hi, Assalamualaikum warahmatullahi wabarakatuh and every good morning to my lecturer of chemistry, Dr. Farida binti Abu Bakar, and to all my friends. Okay, my name is Prizatu Azim binti Maskan and my metric number is DN160292. The introduction of the X-ray diffraction is diffraction occurs when each object in a periodic array catches radiation coherently, producing consistent constructive at specific angle. The direction and intensity of diffraction depends on orientation of crystal lattice with their radiation. Okay, this is the X-ray diffraction technique that used to determine the position of atom in a crystal with an accuracy in the order of 10 to the power of negative 4 nm is same like 1 nm equal to 10 to the power negative 6 mm. Okay, from the slide, we can see the diagram of the features of X-ray diffraction. Okay, type of the features of X-ray diffraction include the production, diffraction, detection, and interpretation. Okay, that's all from me, and we continue with my friends.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muazzam Akmal bin Mazhar. Today I will present about X-ray diffraction. My part is operation principle. So let's begin. Okay, now we'll begin the present for operation principle. Okay, for operation principle, we must know the component first. I will tell the component. In the diagram, we can see first we must have a X-ray source, and then the device for wavelength range is called a goniometer. And then we put the sample holder bottom the goniometer. We continue with radiation detector. Lastly, the signal processor and readout. So all these component must have in experiment for XRD. Okay, we continue to the how XRD works. Okay, XRD works. In the diagram, we can see the X-ray tube in the yellow. X-ray tube will produce a continuous beam of X-ray. The continuous beam of X-ray will incident on the crystal, direct in the crystal. So the diffraction is intense in certain direction. So the example, the direction is correspond to the constructing interference from the wave reflect to the layer of the crystal. Okay, you can see that. After that, we can see the photographic film will show the diffraction pattern for the experiment.
Hello, my name is Adiba Aimah binti Jemali.
Today, I would like to talk about the X-ray diffraction functions. X-ray diffraction can be used to determine strain, crystallographic structure, preferred orientation, and grain size of crystalline materials to compound identification. Deeper functionality available on the crystal structure when X-ray diffraction is used in glancing angle mode. Furthermore, the X-ray diffraction also can help to determine the function of protein and can distinguish between different crystal structures with similar compositions. Besides, organic materials can also be used in X-ray diffraction. For example, as a function of annealing time, the crystallization of polypropylene fibers can be determined. The other function of the X-ray diffraction is to determine the degree of crystalline of the polymer, to state of anneal in metals, and to determine the size of particles or crystallites. This is the X-ray diffractometer functions. Diffractometer is an instrument that to analyze the structure of material. It is consists of shutter light, monochromator, goniometer, slit, sample holder, detector, X-ray optics, and X-ray tube. This kind of part have their own functions. This is the example of the image of the X-ray diffractometer. The monochromator is to isolate a single atomic resonance line from the spectrum of light emitted by the holocated lamp. The goniometer is as a platform to hold and move the sample, optics, detector, and tube. The X-ray tube is the source of the X-ray, while the incident beam optics is to conduct the X-ray beam before it hits the sample. The receiving side optic is used to conduct the X-ray beam after it has encountered the sample. The detector is to identify the number of X-rays scattered by the sample. That's all of the functions of the X-ray diffractometer. Hope it will help you in
My name is Nur Fasil Abdelmashai, and for this chemistry project, I have designed with the simple test that using the X-ray diffraction. And as my friend mentioned earlier, what is the X-ray diffraction, the features, and also the function, I will just straight go through the simple test that using a pure crystal as the sample in this X-ray diffraction test. This test called the X-ray crystallography. Okay, what is actually the X-ray crystallography? It actually a technique that used in determining the atomic and also the molecular structure of a crystal, in which the crystalline atom will cause a beam of incident X-ray to diffract into many specific directions. It had been used a lot by a chemist, physicists, and also by others in the industry. Okay, without further ado, let's see how this test is carried out. To select a crystal that will be used in this test. Since the crystal is such a small material, you will have to fit the crystal under the polarizing microscope. This type of microscope will help you in choosing a better piece of crystal, because usually a crystal will extinguish a light until 90 degrees. Once the crystal is selected, you need to mount it on the tip of the panel very careful, because those crystal is very fragile and easily broke. The crystal need to place on the slide to isolate the crystal easier. Having selected your crystal, you should transfer it onto wax back and forth so that the crystal will stay still on the tip of the pen. Once done, the sample need to flame under the nitrogen flow and place it under this blue nozzle to be struck with the X-ray beam. Then, when the structure of the crystal appear on the screen, you need to adjust the position of the pin until the appearance of the crystal is completely clear. The resulting structure is to be refined to fit the light more accurately and to adopt a thermodynamically further information. And you can also determine the unit cell of the crystal by collecting preliminary diffraction data, or known as the metric line. Okay, for the extra information, X-ray crystallography is the most favored technique used for determining the structure not only for crystal but also in biological macromolecular of protein. The extension of this technique gave a wide appeal of crystallography that clarifies systems such as the viruses, immune system, and also the protein nucleic acid complex. So that's all for my presentation on the sample test for the X-ray diffraction for my group. Thank you.
Assalamualaikum, my name is Tuan Muhammad Mar. Today I want to talk about data analysis of X-ray diffract. Two-dimensional position sensitive detectors. For many years, two-dimensional position sensitive detectors have been used to collect X-ray diffraction data. Data from crystal of macromolecules such as proteins, oligonucleotides and multi-wire system, and charge coupled device (CCD). With all these detectors, the crystal center in the X-ray beam is rotated or oscillated around a single axis through a small angle of 0.1 to 2.0 degree, while counts from diffracted photons are accumulated for a specific time. Thick and thin. Those data sets consisting of relatively large rotation angle increment where each image contains a number of fully recorded reflections will be called thick. This is defined for our purpose here as increment greater than the effective mosaic spread of the crystal. Those with relatively small rotation angle increment where each image contains predominantly partially recorded reflection will be called thin. Thick and thin data sets. Refer the data set from thin and thick data a frozen crystal with a mosaicity of about 0.4 degree collected with CUKA radiation and the same experimental hardware into different rotation increment 0.25 per image and 1.5 per image as shown in table 1. You can see here rotation angle increment per image. Thin is 0.25, thick is 1.5. Overall rotation, thin is 0 to 45, thick is 0 to 45. Exposure time per image, thin is 120, thick is 720. Exposure rate, thin is 8, thick is 8. Total exposure time, thin is 6, thick is 6. Number of image, thin is 180. Poissonian process. First diffraction behaves as a Poissonian process. Thus, if you want to count X-ray photons and not arbitrary analog to digital units ADUS, the variance of an observed value of photon Q is simply the value of photons. Okay, this is Poissonian process. This is the formula. Bragg peak. It follows for a relatively simple integration of a Bragg peak containing diffracted X-ray photons. From table 2, the relative error is shown as a function of observed intensity and background values for the background values of 500 and 1000. From table 3, it is clear that any additional error or noise per pixel is less deleterious to thickly sliced image than to thinly sliced image. In the latter case, more pixels are required to integrate or observe peak pixels. Table 3 shows some hypothetical values since modern detectors do not contribute 50 photons per pixel of noise. This is the result. In figure, resolution for reflection integrated by both dTrack and HKL from 180 image dataset and from 30 image dataset. The data collection parameters are described in table 1. The only difference between thin and thick dataset is rotation angle increment per image. The crystal was frozen and kept at 100 Kelvin. The detector was NR-axis equipped with a MSC Yale total reflection mirrors.
Assalamualaikum warahmatullahi wabarakatuh. Thank you to my friend and our lecturer, Puan Farida binti Abu Bakar. I want to explain about the conclusion of X-ray diffraction. The conclusion is the X-ray diffraction is a technique analyzing structure of biological molecules. Second, X-ray beam hits a crystal, scattering the beam in a manner characterized by the atomic structure. And the X-ray also diffraction can be analyzed the complex structure like DNA and protein. Lastly, X-ray diffraction techniques that combining knowledge from physics, chemistry and biology can be useful in future. X-ray are also the tool of choice, and their scattering of the crystal at a certain angles give us the ability to apply Bragg's law and solve the distance. Because of the small distance, we are required to measure the atomic separation indirectly by use of electromagnetic radiation. This is due to the fact that visible light has wavelength in hundreds of nanometers. Effectively, barring us from visually resolving the X-ray diffraction are also not expensive and most convenient worldwide use method to determine crystal substance. X-ray also are not absorbed very much by air, so the sample need to be in a evacuated chamber. However, the disadvantage of X-ray is not interacted by strongly with lighter elements. That's all from me for the conclusion of X-ray diffraction, and thank you to all.